So today we are going to see Leetcode question that we have is 211, that is design, add and search word data structure. Okay, so let's read this question. Okay, design, add and search words in data structure. Question is saying design a data structure that support adding new words, right, and finding if a string matches any previously added string. Okay, so we have a word data dictionary, right, word dictionary class, and we have word dictionary that initializes the object. Then we can do add word, and then we will search the word. It will return boolean, either true or false, right? And add word will do not return anything. It will just add a new data word and data structure that can be matched later, right? And it's also saying word search returns true if there is any string in the data structure that matches word, or false. Otherwise, word may contain dot, where the dot can be matched with any letter. That we'll talk about this later. Okay, now think about this example in which we have given first to initialize the dictionary. Then the activity is we have to add, then we have to do add, right? Here we also had add. Now we have to do what? Searching. We have to do searching, we have to do searching, we have to do searching, right? Like this. So as you can see, first we are going to initialize, then we are adding, right? We are adding here, we are adding here, we are adding, right? Then right, we have done. And after that you can see we are going to search, right? We are going to search, and search. And in this way if you'll see that we have added this dot ad, right? And in the last we have added what? Pad. And we are searching what? This one, right? So we are getting true. Where is also there, add is also there, and we double dot is also there, right? So you can say these words are there. Now understand what is happening here actually, right? So first of all, we have a dictionary, right? Let's suppose this is similar to a data structure dictionary. First we have added what? BAD, right? Next time what we have? DAD, right? DAD, like this we have added. So these elements we have added. Now we are searching pad, right? So we will go and check is pad is available in this one. So we don't have here, right, that we have added. So it is given false, that is true, right? Now we are getting BAD, bad. So we have already added here, right? So we will get true, right? Now we will get at the place of B, we are adding dot add dot and AD, right? So you can see if we will consider dot as a B, then we will get this data, right? Or you can say AD, MAD, right? These AD is already in there, and dot is means multiple we have, you can say. Okay, and yeah, you have the data. And B, two dots we have, we can say yes, we have the data. That's why this sentence was saying while doing the search, if there is any string in the data structure that matches word, or we will return true, right? And if not, then we will return false. Otherwise, may contain dots, where dot can be matched with any letter, right? That can be any letter or multiple letter, you will say. Now we have constant, that means length of the word can be greater than 1 and less than equal to 25. Word in the add word consists of lowercase English letter, and we'll search you can say with the dot lowercase English letter. There will at least at most three dots in the word, and search queries. So at most 10 to 4 calls will be made to the add word and searches. So these are constant, and this question is very important because this question has been asking Google, Amazon, Microsoft and Apple, the top companies, right? And this topic is very important because this is a related string, DFS and design and Trie, right? So this question is based on design. Yesterday we also have seen a design question, then you can see, right, in which we have seen the Trie, right? So you can see, so you can do the practice also, that will help you, right? So there will be some methods are given, empty method, you have to implement this one, right? So you should familiar with how trees work, right? If not, you can do the tree implementation, right? Now understand why we are going to understand the data structure that is called trie, right? So let me write here. So the data structure, we can say trie, why it is important, right? So data structure trie, it could pronounce in two different ways, right? Some people also say tree, right? And some people also say trie. Okay, so you can pronounce in two different ways, right? It can pronounce in two different ways, you can do that. So trie, which is also called a digital tree, right? Or you can say prefix. Some people also say this trie as a, you can say digital tree, digital tree. Okay, and some people also say it's prefix tree, prefix tree, right? So trie, which is also called, you can say, digital tree or a prefix tree, is a kind of, you can say, search order tree, right? If we'll talk about search order tree, right? So you can say this trie or digital tree or prefix tree, tree, right? You can say is a kind of you can say search order tree data structure, right? So that is, you can say, it is mostly used for efficient dynamic, you can say dynamically you can add or search operations in the string, right? So if there is a, you can say, dynamic add or you can say search, then you can use this data structure, right? And trie is widely used in real life actually, like that we have already seen yesterday. We can use autocomplete search, spell checker, T9 prediction, predictive text, right? That we can use IP routing, right? Those are the things then where you can use this one, right? And if we'll talk about how does it works, right? That we can see soon. Okay, so let's talk about this example, right? And we will understand how this works, right? So if we'll talk about we are going to implement, let's suppose we have two methods we have to implement, the add and you can say search. So what we will do, we'll try to understand this one, right? Okay, so first understand how to implement the, you can say, trie, right? And you can say trie, and we will implement the add word function, right? Because once we will add this one, so our trie will be ready, then we can do searching, right? So we have input string, we have oat, dig, dog, dogs. Okay, let me now understand, this is a trie. Let's suppose this is our trie. We are going oath. First we will go O, then we are adding A, then we are adding T, and then we are adding H, right? And if we are doing the search, once we will reach here, right, we will get true. Similarly, we have dig, so we will write D, I, and G. If we will do the search, we reach here, we will return true, right? So this is also dog, this is also done. Now we will come to dog. So we already have added O and D, so we will start with D. Now we will add O, and then we will add what? G, correct? And if anybody search, it will return true, right? Because we have D, O, G. Another we have what? Dogs, S. So we have already added D, O, G. We only have to add one more here, that is called S. And if anybody search dogs, we will return dogs. I think you have got how to implement the add words, right? So if we'll talk about adding, right, let's suppose we are doing what? Dog we are adding, right? So existing is already what? We have D, O, G, right? We have added. Suppose we have added oath, we have added here, we have added oath, correct? This oath. Then we have added what? Dig, right? And we want to add now what? Dog. So D is already added and OG we have added. Okay, now this complete DOG is required when we are going to add dogs. Only we have to add one more S, right? And then we will add, that we have already seen, right? So when we are doing dog, reuse existing node. So these DOG are the existing node, and we are going to use this one, right? when we are going to add a new node, right, so we will reuse these existing nodes, right, and that's why it's become faster, you can say dynamic. Now think about searching, right? So what we will do before searching, what we will do, we will implement our, you can say, tree data structure, right, trie data structure, and we'll try to implement this one. So going forward it will become easy at this browser. Okay, so what we will do, first of all we will implement a class that is called, you can say, class tree node. We start trie node, right? Let me write one more e here, and then this class will contain what, two things. The first, it will take you can say word, right? So when people are searching, it will return boolean word, and it will return what, by default false if not there. Then we will write one you can say pair of character and its node, right? So what we'll do, we can do map, right, and this map will contain what, character, and another should be what, trie node, its node, like this, right? And this is nothing but our what, children node, right? And if we'll do what, new has map, like this. Once this is done, right, we should create one default constructor to create constructor. I'll write public trie node, and then that's all, right? Now our trie node is ready. Now what we should do, because our node is ready, so I'll say in the word here trie node, and we'll say this is our trie, correct? Once this is ready, trie, we will initialize this one if it is required. So trie equal to new, you can say trie node, got it? Now this is done. Now we will do add word, add, right? So to add a word into data structure, what we will use, first of we have the trie node, and we'll create our you can say current node, right? Current, and say node. Let's suppose we have current node, and this is nothing but our trie, okay? Or if you'll say let's suppose not current node, let's suppose this is the node, okay? I will start from here, okay? Or you can say root node, we can also say. So I'll take as a node, okay? Then we'll take what, a loop from we have this word that we are passing. From the word we'll do 2-char array, and we'll get all its array, character array, one by one character we'll get, right? To get that character, we'll say character c, you can say like this, okay? And then one by one character will take, and we'll check if this node doesn't contains, let's suppose doesn't contain this what, contains key of this character, okay? If this character is not there onto the child elements, you can say child nodes, as a child nodes, means we have to do what, put, right? And then we'll do what, put. If this is not visited, you can say we should visit, like that, means we don't have, right? Then what we will do, we'll do new trie node, like this, got it? After this, what we should do, we will create one node, we will update its node, right? We'll update node, current node equal to what, it's better you give the name current node only. Now you have to update your current node, and we'll say get from this character, right? I'll give the name current node, because it's very good to understand. So this is your current node, right? And from the current node, what we will do, we'll check on the current node, or let it live. You understand? Okay. Once this is done, what we will do, we'll say this loop, right, is our node dot word, and we'll say true. Got it? Once this is ready, right, we will do our search thing, right? And to do search, let's go to understand the search one. Okay, so what we are doing here, actually, we have created what our class that is called tree node, and we have initializes this in the word, and then we are doing what, we are from the given words, we will while we doing add, we will check first onto the you can say node, if this is available, it's fine. If it is not available, then we will add, right, onto our children map. Otherwise, what we will do, we'll update our node from we will get our node, and then we'll say node dot word is true, right? So we'll do that, and then we'll come to our search. So let's go to understand the searching. Okay, so now we are here. Let's understand you can say search in Trie. So how we'll implement search in Trie, right? So if our Trie is ready, Trie is already ready, our dynamic Trie is already ready, then what we will do, let's suppose we are going to find what we can say, to find the oath, right? Let's suppose what we will do, first we'll go with O, then we'll take A, then we'll take T, then we'll take H. Oh, this is there, we'll return true. If someone is going to find dig, we'll go to D, I, G, and will return true. If anyone going to find O, G, right, D, O, G, we get this. Otherwise, what we'll find, S, dogs, we'll also say true, so it will return. But if you're going to find digger, what will happen, D, I, G will get, next we don't have here, right? So what will happen, it will say false. Coming to the presence of dot, right? If anyone is going to find IG, right? So see, we have IG here, right? So what will happen, we are starting from D, it will not go to this D, O, this side, right? It will go to this side. So we will find D, I, and there is a G, right? So if it will go first here also, right? It will go here also, it will go further. So if it is going to after this, right, in the first element, if it is going to next element, right, there is no I, so it will not go here. If like this, if we'll going to this way, right, so if the next element is O, it will not go here. But if we find next is I, so it will go this line. So next element is G, so he will going to find G, it will return true. Okay, I think you understood. So what we will do, let's go to understand the we have to do some searching, right? So we have given what search we have given, right? So to search this one, what we will do, we should write some implementation of searching, right? So to write this implementation, what we should do, we'll create one you can say search, right, and we'll do the implementation. Okay, so to search, what we should do, we will write a return, and then we'll create one search function. So search, we're going to find search in, you can say node, right, search in node of, you can say Trie, right? So how we will find this, actually we will pass this word, and we'll also pass what, our Trie, this one. Okay, and it will return this one. Okay, so to do that, we will create this function, that is all our, you can search in the node of Trie. What we'll do, we'll say this is our public, and it will be return boolean also, and this method will remain same as a search in node of Trie, right? And it will pass what, it will take a string word, and another what we have Trie, right? So we'll take Trie node, sorry, we'll say Trie node, and this is nothing but node. Coming to here, what we will do, first of all, we'll start the index, right? I'll start with index I equal to 0, and we will go to we have word, right? Word dot length will go, sorry, we have a word dot length, and its length till will go, and I plus plus. So one by one character will get and will check onto the node. Let's suppose we have character C equal to nothing but our word dot, you can say, caret our I. So at each word will find onto the node. So we'll check if not node contains element, children, right? It was children, and then we'll check what contains key, and we'll check what C. If this is not available, we will put, right, we will put there. So we'll check if here C, the C character, if character equal to what we have, dot we have, right? Then what we will do, we'll check, you can say, we'll do a for. Let's suppose we'll go to the next element, right? So we'll take what we another element we have character. Let's suppose X we have, or you can say character C only. Let's suppose C1 will check. Okay, so we'll check the next element. We'll take node, and we'll do what, let's suppose children. Then we'll check, we'll make a key set. On the key set, we'll check, we'll get all the characters one by one, and then we'll do we have trie node, right? Let's suppose this is our child, and we'll do our node dot children dot, you can say, get C1. Okay, so we'll get our child, and on the child we'll check if search in you can say node will try to find what we have given the word dot, we can make a substring, right? We can find substring from what the given index I, and plus we'll do from plus one, will from start with. We will not consider dot. After the dot, we'll consider all the character, then the given children, right? I think understood. And then we'll return return true. Okay, once this is done, right, then return true. Else what we will do, will once this is done, right, our ch will return what, false. Here return false. If not, that is not the case. Otherwise what we'll do, if the character is not into that, we will put into our, you can say, onto the map. So to do that, what we'll do, we'll add node equal to the current node, right? Current node will, you can say this one. Then we'll do what, get, and this is our character C. After completing this one, right, after completing this node, right, we are completing our for loop. From the for loop, we will return now node and dot the, if you have word. Okay, so I have not done nothing big thing, just created one search in node, this word, and while searching this one, right, we are passing word and node. So what we'll do, we'll start with all the character 0 from of the word. We'll get one by one character from the, or you can say word. We'll check onto the map. If not available, then we will what we will do, we'll update our node, right? We update our node if it is there. If not there, then what we will do, we'll go to check first dot. We'll get a set of you can say key set, and from there we will check not on the dot, we will check the next element after the dot. If that is there, we will return true. If not, we will return false, right? And we'll implement this one, right? So if we'll talk about let's understand one more time, right? So what we will do, what we have done here, we have started with the tree node, and then we have created one add node, right? And then we have done the search thing. So while doing this this one, right, while we are adding this one, so if we'll talk about the time complexity, right, so it will take what, the searching, adding, it will take, let's suppose, uh, you can say the length of the word, right, it will take m, so it will become tc will become, you can say o of m, if m is the length of, you can say, key. Okay, and if we'll talk about the space complexity, this will also take all the you can say word to store. Okay, and if we'll talk about the searching, right, only the searching will not take any extra spaces, right, so I'll write here only. Okay, so this will take extra constant time, and this will remain the same. Okay, so guys, if you like this video, you please hit subscribe so that you will get more videos like this, right, and thank you for watching this video. Okay.